Welcome to the ChemDoctor, and this video is in response to a request that I had on my website asking for more videos regarding practice calculating theoretical yield of chemical equations. So let's go ahead and get started. In this case, what I'm going to do is have a chemical reaction between sodium metal and bromine to produce sodium bromide. We are going to calculate the theoretical yield of the sodium bromide. All right, so let me write that down here. We're going to have theoretical yield of the sodium bromide. And to review, remember that theoretical yield is the maximum amount of a particular product that can be formed during a chemical reaction if all of the inputted material, all of the material that we put into the reaction, reacts to 100%, and that the reaction is allowed to occur to 100% with no losses. So basically the theoretical yield represents the maximum amount of a product that we can produce during a chemical reaction where that chemical reaction is 100% efficient and that there are no losses. And this is a quantity that chemists always calculate when they're going to carry out a chemical reaction because they need to know the maximum amount of material that will be produced in a reaction in the way that they've proposed to carry it out, so that when they actually do the reaction in the laboratory and acquire experimentally the amount of product, they can determine what's called the percent yield. And the percent yield is a way or a method where they can evaluate the efficiency of what it is they've undertaken in the laboratory. Now in this video, what we're going to do is carry out a simple calculation regarding a theoretical yield. So in this case, what I've inputted into the reaction is 1.8 moles of sodium. And I'm stipulating that the other reactant is in excess. We need to say something about the other reactant, and by using the term excess, all we mean to say is that when we put 1.8 moles of sodium into the reaction, we are going to make sure to include enough bromine to react all of the 1.8 moles of the sodium. All right, so let's go ahead and get started. Now the way I recommend that you do this is you pull down, I call it pulling down, the amount of the reactant. I'm going to rewrite it, careful to include the units and any symbolism that tells us what this material is. So we need to include the label that tells us that this is 1.8 moles of sodium. Now in a calculation regarding theoretical yield, note that you always need to be in the units of moles, and the reason for this is because the coefficients from the balanced equation, that's these numbers here, are in units of moles. So for any calculation involving a balanced chemical equation, the units that you deal with always need to be in the same units of the coefficients, and therefore we need to have the quantity of input in the same units as the coefficients. And we already have that done here, so we can go ahead and move to the next part of the calculation, which is to use a ratio from the balanced equation to actually solve for the sodium bromide. So I'm going to use a multiplication sign and then a fraction bar and then an equal sign to show what it is I've solved for. And over here I'm going to write what it is I've successfully solved. It will be moles of sodium bromide. And then coming back to my fraction bar, we're going to use the mole ratio that comes from the balanced equation. Basically, in the top of the fraction, what I want to use is the coefficient from the thing that I'm solving for. So we're going to have a 2 here from the balanced equation, and then our label, it's sodium bromide. Underneath, we're going to have the coefficient from the thing that I want canceled, so we need the 2 from the sodium, and then we need the label that identifies the thing that is going to cancel. And now you can see we've got 2 NaBr over 2 NAs. The 2's are going to cancel. Whoops. Let me get a color on that. The 2's are going to cancel like this. And then the sodium cancels with the sodium here. So we've successfully solved for 1.8 moles of NaBr. Now, in most of these problems, you're going to be asked to find the mass, the theoretical yield in mass of the product. So I'm going to go ahead and set up a multiplication sign here, and we're going to convert moles of NaBr into mass of NaBr. To do that, we need the molar mass of the compound NaBr. So I look up in the periodic table, and if you need to do that at this point, please pause the video and go to a periodic table and calculate the molar mass of NaBr, then come back and see if your value agrees with mine. All right? So I'm going to pause for a second so you can do that. Now, when you look up on the periodic table, you'll see that the sodium is 22.99 grams per mole. The Br is 79.9 grams per mole. All right, when I sum these two values together, I get a value that is 102.89 grams per mole. All right, hopefully this agrees with what you got when you sat down and did this for yourself. This goes into this fraction now. All right, and we see that the sum total then, when you multiply these out, so this is going to be over 1. We see moles cancels with the moles here, and we're going to end up with grams of NaBr over here. All right, and what you should have gotten here is going to be about 185.2 grams after you run the calculation. All right. Now, this represents the theoretical yield, so I'm going to go ahead and label it the theo yield of NaBr that we would form in this reaction if all 1.8 moles of sodium reacted, the reaction went to 100%, and there were no losses. All right. Now, what I would like to do is thank the viewer for watching. I really appreciate it. You can find more videos at www.chemdoctor.org. Please come back for more.